Hey everybody, Harold here. In this video, I want to talk to you about lazy evaluation in polars, the real power of polars. You can scan and manipulate huge amounts of data that pandas just can't handle. A little comparison on the data scale, pandas versus polars. How much can pandas handle? The rule of thumb is it's memory bound. If it doesn't fit in your memory, you're in trouble in your RAM. In practice, comfortable with hundreds of megabytes. It's okay to tune stuff with 1 to 5 gigs. Painful and risky with 10 or more gigs. If your data is larger than your available RAM, that's just a hard stop. Um, why? Because Pandas uses eager execution. It loads everything immediately. Uh, Python objects and NumPy arrays have a high memory overhead. There's no query optimization plan, native pandas, and it frequently copies data. You could stretch it with chunking, data type optimization, or categorical, but it's manually complex and your pipelines are fragile if you do that. How much data can Polars handle? Polar scales beyond RAM, comfortable with many gigabytes, common with tens of hundreds of gigabytes. The realistic upper bound is the size of your hard drive and your patience. Polar scales better because it's written in Rust, uses arrow, lazy execution with the query optimization, streaming execution, zero copy operations if possible, and it's multi-threaded by default. So Polars can handle a lot of data a lot faster than Pandas can. Little housekeeping, we're in Colab again. We're going to import Polars as PL, and I like to import rich from print for pretty printing. The ways to create a LazyFrame, three basic ways: from a dictionary, Python dictionary, from an existing data frame with the .lazy command, or pl.scan from a file. So from a Python dictionary, I would say something like lf equals pl.LazyFrame, not DataFrame, and then put a dictionary in. So I don't know, pool, and then it's your key, it's your column heading, your values are a list. I'll say hammer, saw, wrench, and we'll give it another column. Quantity, 3, 4, 5. Down here, I have to say dot lazy, and then print LF. I get my plan again. And the third way, and I've uploaded a file called order CSV. If you want to upload a file, you just do this in the files. I'll put the file in my GitHub repository. The second way you can create a data frame is from an existing data frame using .lazy. So I could say lf equals pl.dataframe, and we'll just use this. Down here, I have to say dot lazy, and then print LF. I get my plan again. And the third way, I've uploaded a file called order CSV. If you want to upload a file, you just do this in the files. I'll put the file in my GitHub repository. So the third way is scan from file. It's a CSV. So we say LF equals pl.scan CSV, order CSV, and print LF. So there it is. We've scanned order CSV. Haven't done anything with it yet. Just scanned it in. To display the result, we use the collect method. So let me recreate tool. And it works best with lazy execution engines like Polars and Spark. Uh, Simple predicate pushdown example. Filter the tool column for hammers. So query equals lf.filter. Same command as the df. The optimization consists of predicate pushdown. It applies a filter as early as possible when it's scanning. Projection pushdown selects only the required columns at the scan level. And slice pushdown loads only the required slice and avoids materializing slices. This matters. It's less data for faster execution. Lower memory usage for better scalability, and it works best with lazy execution engines like Polars and Spark. Uh, Simple predicate pushdown example. Filter the tool column for hammers. So query equals lf.filter. Same command as the df. pl.call tool equal hammer. Then I'll print that query. Remember, I'm just printing the query, not the data. Sorry, I used too many equals. So the naive plan, first predicate pushdown, applies filters as early as possible at the scan level. So it filtered it first, then it selected the columns it wanted. So it's not reading that row by row. It's only looking at that tool column and a hammer, picking out the rows with hammer. And if we print, let's collect it. Print query, collect. It's a bound method. And here we have tool hammer quantity 3. So we collected it. Now it's in the memory, in the RAM. Um, Group by tools, some quantity. Let's do a little more difficult one. So query equals lf.group by tool dot ag quantity dot sum, and we'll print the query. So now that's a little bit more complicated. It's selecting tool, then it's aggregating quantity by tool, and projecting out the two columns, tool and quantity. Um, See the optimized equals true. Let's see that. So I can just say query dot explain optimized equals true. That'll show you the optimized plan. It's a little different. Select alias tool. It's a string. Quantity is a list of int64s. Aggregate and maintain order is false. Aggregate quantity by tool. From tool and quantity project 2 columns. And they even have a graph to show you what's going to happen. So I could say print query dot show graph. And it's got a cool little graphing thing. It's 2 columns, aggregate quantity column by tool, return a 2 column table. So that's pretty cool. The little graph thing. Uh, Execution, like I said, scan. So let's put order CSV back in there. LF equals PL dot scan CSV orders dot CSV and print LF to see the plan. 8 columns. Order CSV gives it an ID. Let's see the first 5 rows. So print LF dot collect dot limit 5. So there's the first 5 rows of the orders data frame. Just some product, order numbers, customers, dates, etc. For this example, to show you a little more complicated stuff, change product to all lowercase and filter to only laptop. Query equals LF dot with columns, TL dot call, product, and I'm gonna do string methods later, but dot str string dot to lowercase. And I'm gonna filter TL dot call tool. I'm sorry, product equals. Since I've already lowercased it, I can just say laptop. And let's explain that query. So it's going to filter column product for laptops from with columns. Show the graph on that one though. So filter by column product. It's already started just taking out laptops. Then it converted it into lowercase. Then it scanned all those columns and returned 8 columns that met those conditions. And as mentioned above, to execute the query we call collect. So print query dot collect. And there it is. Laptop's all lowercase. It's only laptop. I could have put the collect in my chain and then I wouldn't have. And it just printed the query that way. Also. just to show you that. Last but not least, if you have that huge amount of data that doesn't fit in your RAM, of course, this will, let me copy this down here real quick. You just put a collect on here and say engine equals streaming. And it will stream it all in, only streaming what'll fit in your RAM. So that's how lazy evaluation works in Polars. I hope you liked this video. If you did, please like it and subscribe, and I'll see you next time. Thanks, everybody.